Today, I want to talk to you about pi, the number, and about Pi Day, and about why mathematicians even bother celebrating a day about pi, except, okay, for the obvious excuse of eating pie. I want to look at the mathematics behind pi and explain to you why I, as a mathematician and an educator, think that pi is special. This is actually a fairly controversial opinion among mathematicians. There are a lot of really great mathematicians out there who think for various reasons that pi just isn't worth celebrating. But I want to take a couple minutes to convince you that pi is special and that Pi Day is definitely worth your time. But I don't want to get ahead of myself, so let me start by reminding you what pi is. Pi is a number like 37, and here's how you can calculate pi. You draw out a circle with diameter 1. And with this scale, you take a tape measure or a piece of string, and you wrap it around the circle, and you use that to measure the length of this one side. You should get this length to be about 3.14, and as you get more precise with your calculations, you can find more and more digits of this circumference, and okay, now we're probably beyond the technological power of your tape measure or piece of string, but say we had a computer doing the calculations, we could find a lot of digits of this circumference length. So this is the number we call pi. It's just the circumference of a circle with diameter 1. You should be asking yourself, okay, why is that so special? And there's a default answer to this question, which is that if we kept looking at more and more digits, if we made our calculations more and more precise, these digits would have no pattern among them. They never repeat in any sort of sensical way. They're seemingly random all the way to infinity. This boils down to the fact that pi is irrational, which literally means that it can't be written as a ratio or a fraction, and that we can make fractions like 3 over 1 or 22 over 7 that come very close to pi, but none of them will ever be exactly equal to pi, because fractions have nice repeating patterns among their digits, and as we just said, pi does not. Okay, so pi is irrational, and its digits never repeat. So this is exciting, right? Well, it turns out that being irrational is actually not that mathematically exciting, hence all the skepticism about Pi Day. There are tons of irrational numbers out there. For example, the side length of a square with diagonals 2 is irrational, about 1.4. And the height of a triangle with side lengths 2 is also irrational, about 1.73. Leaving geometry for a minute, I want to talk to you about one last irrational number, phi, or the golden ratio. And here's how you construct the golden ratio. You start with a square, a 1 by 1 square. Next to this square, you put another square. So you have a rectangle. And next to this, you put essentially the largest square you can, which in this case will be 2 by 2. And next to that, you put the largest square you can. And you keep doing this, getting bigger and bigger squares as you spiral around until you run out of room on the screen. This shape is called the Fibonacci spiral. And what I'm going to do is I'm going to outline in yellow the rectangles that we get at each stage of constructing the Fibonacci spiral. What I'm doing here is I'm calculating the ratios of the sides of these progressively larger rectangles. You can see that they're all around 1.6. And computing a bunch more, way beyond the scope of our screen, we see that these tend to be approaching about 1.61803. If we computed a bunch more, we could find many more digits of this value that these ratios are approaching. We call this limit phi. This is the golden ratio. And we call phi golden because things that are proportional to phi tend to look nice. We see this in architectural wonders, in modern design, and on everyday playing cards. Phi shows up in nature, in the spirals that make up flowers and plants and fruits like pineapple. Even the dimensions of a spiral galaxy can be closely approximated by phi. And phi is definitely irrational. Like pi, its digits go on forever with no sort of obvious pattern to them. And this begs the question, why don't we celebrate Phi Day? Why don't we get together on January 6th or June 18th, and we can all play cards or go stargazing or eat some delicious pineapple together? I mean, we're literally surrounded by phi. It shows up in so many unexpected places. And mathematically, it's not that hard to explain phi. And so, why pi? What makes pi so special? Why don't we celebrate Phi Day? And to answer this question, we're going to have to get our hands dirty with a little bit of math. So what we're going to do is we're going to use Google's calculator to compute phi squared, or phi times phi. You can do this on your own, or I can just show you the result, that phi squared is about 2.61803. And here's a bunch more digits. These numbers should look familiar to you. If they don't, allow me to jog your memory by showing you phi. You should quickly notice something cool is going on, namely that after the decimal point, every single digit of phi and phi squared is the same. And most importantly, this means if you take phi squared and you subtract away phi, you're left with exactly 1. Or doing some algebra, phi squared minus phi minus 1 is 0. And this is actually amazing. Because remember, we said that phi was irrational. Its digits literally make no sense. They have no pattern. Yet, we can do a little bit of math to phi, and we can get back to 0. 0 makes a ton of sense. We know every single digit of 0. Numbers like this are called algebraic, which literally means that they come from algebra. Their digits might not make sense on their own, but you can hit them with some basic math and get back to some rational number like 0 that we understand perfectly. Remember the number from the square earlier? It turns out if you square that number, you get exactly 2. Or the one from the triangle? If you square that number, you get exactly 3. While some of these irrational numbers might not have digits with any patterns on their own, there's some very basic math you can do to get back to rational numbers. So what about pi? Is there some math we can do to make sense out of pi? And we can try it. We can compute pi and pi squared and pi cubed and pi to the 4th, and we can do math to them. We can add them and subtract them and multiply them together. But no matter what we do, no matter how creative we are, we will never get back to a rational number. That's because pi is not algebraic. Numbers that aren't algebraic are called transcendental. They literally transcend, they go beyond the very notions of arithmetic. The basic mathematical tools that we learn in elementary school are totally useless when it comes to trying to understand the digits of pi. They're just that random and confusing. So when we ask, why don't we celebrate Phi Day? Well, while phi is irrational, it's the boring kind of irrational. It's just algebraic. And what makes pi so special is that pi is transcendental. The skeptics are probably pretty upset right now, because it turns out that being transcendental, well, that's not very mathematically exciting either, in that there are a ton of transcendental numbers out there too. I mean, there's pi and there's e, which most people learn about by the end of high school. And, well, then it gets really hard. It's hard to find transcendental numbers. We don't even know if pi plus e or pi times e are transcendental on their own. Okay, with a pretty solid grasp on things like trigonometry or logarithms, it turns out to be not that hard to find transcendental numbers, but here's pi, which is so simple that we can teach it to an elementary school classroom as a length of a circumference of a circle, yet so complex that its digits defy the basic notions of arithmetic. They're uncertain and random, and this gives us this glimpse into some of the complex questions that underlie math. Pi gives us this intuitive introduction to the idea that there's so much more to math than addition and multiplication. There are complex and unanswered questions that are embedded throughout our mathematical system of rules, and here's Pi just inviting you along for the ride. So next March 14th, I encourage you, eat some pie, and remember, this is not only a number that's exciting because its digits never repeat, but you're celebrating something that is simultaneously so simple to describe, yet mind-bogglingly complex and mathematically impossible to fully understand.